You have seen how to write a service server in C++. This time, you will learn how to write it with Python. To understand the scope of the programming you'll be writing, please refer to the C++ version. So I'm going to open the terminal and then go to the workspace and then src and the package total control. Then we want to go to the scripts folder. So inside the scripts folder, we're going to create our file. Now what we want to write is called Euclidean Distance Server. So I'm just going to call it edc or eds.py. So that is Euclidean Distance Server. Okay, you can now go back to the workspace and open VS Code. All right, so this is what we did previously. Then we're just gonna open the Euclidean Distance Server.py. Okay, just to reiterate, what we want to do is to write a server that is gonna calculate the distance between 2 points in the total sim, and then those distances are gonna be input from a client. So the client is going to tell us the distance they want to calculate, and then the server is going to take the position of the total in the total sim and then gets the new position from the client and calculates the distance between the total in the total sim from the position from the new position that the user is going to input. Okay, so that's the client and the server. But then we have to write the server first, because without the server, the client is not going to work. Okay, so the first thing we want to do is to, as usual, put our shebang. So just going to put this here, usr /bin /env, and then we have Python 3. All right. So then we want to start importing the libraries that we need to use in our code. The first we want to import is the Rust client library. Without the Rust client library, we cannot use any Rust features in this code. And then we're going to import the node class, the RCL py.node. Okay, from that we want to import node. Great. Because we're using a service file, we need to import the service we're going to use. All right, so the service we want to use is example interfaces.srv. So from example interfaces.srv, we want to import twist node add to int. We want to import our two ints, and then because we'll be getting the pose of the total, we need to import the pose as well. And remember, the pose is inside, what is inside the pose is the total sim message. So we're gonna do from total sim.msg, then we want to import pose. Okay. Now, the last thing we're going to do, because we want to compute the distance between 2 points. Now, these points are points on the total sim, and then we want to calculate the distance between those 2 points. To do that, it's going to look like some kind of mathematics where we have the x2 minus x1 squared plus y2 minus y1 squared, and then we take the square root of everything. So we're just going to import a library called numpy to help us handle that. So I'm just going to say import numpy as np. So if you do not have numpy installed, or if you're not sure if you have numpy installed, you can just check from your terminal. There are different ways to check if you have numpy installed. You can use the Python 3 mp, and then you say show numpy. So if you don't have numpy, it's going to show you a warning that you don't have numpy. but in my own case, I have numpy. You can also use pip3 and then say pip3 show numpy. So to install pip, if you don't have pip installed and you want to install pip, you just type sudo apt install python 3 and then you do pip. So this will install pip3 for you, but if you already have pip3 installed, you can just do pip3 install numpy. So this is how you install numpy. So pip3 install numpy, and then it's going to install numpy. So let's go back to the code now and continue with where we start. So now we have successfully bring in the libraries that we need for this code. Okay, so the first thing we want to do now is to declare some variables. So just going to declare a variable called x1, and then I'm going to initialize x1 to 0 or 0.0, just make it a float. So you can then declare other variables, but because I want the other variables to also be 0.0, just kind of initialize everything to 0.0. I'm just going to do x2 x2 is equal to x1 is equal to x2, and then it's equal to x3. No, it's equal to y1 rather, and then equal to y2. Okay, so this way I said x1, x2, y1, y2. So these are the points on the total scene. All right, now if you notice carefully, you realize that the code we have been writing on our previous Python, the avoid word and the counter.py, they are all object-oriented programming where we use classes in the codes. But this time, I just want to show you that you can actually write a code in a ROS2 code or a ROS2 Python code without using the object-oriented programming. So you can just basically write a functional programming and it's going to work fine. The only thing is that the way ROS2 is structured, it's kind of difficult to write just pure functional programming without OOP. It's kind of difficult and it's not even advisable because you will be so much limited to some things. So the best way to program for us to using Python is to write object-oriented programming where you use classes. But for this case, I'm just going to use functions. I won't use OOP just to show you that you can still write your code without object-oriented programming. All right, so I'm going to declare a function. I'm going to make a function and call it post callback. So let's just call it this way, post callback. So this is where we get the post of the total and then we store it somewhere. Okay, so post callback is going to take a parameter. So, and that is going to be total underscore post. It can be anything you want to give it. And just inside here, we will initialize it. So we're taking the post and then we're putting it inside total post. So total post is an instance of post. That's basically what we just did there. Total post is an instance of post, meaning that total post can access all the attributes inside of post. And what are the attributes inside of post? Attributes like x, like y, like angular, linear, velocity, angle, and some other things like that. So we're just gonna put it this way, and then we want to access the x1 and y1, so we're gonna make it global. So global means that we're not trying to make a new x1. We are referring to the global x1 on line 9. Okay, so we're gonna make another one too, global, and then we store x1. We do total post.x. So remember, total post is an instance of post, and so because it's an instance of post, it can access the attributes of post. So one of the attributes or one of the variables inside post is this x. So we can access the x coordinate of the total, and then we store it inside x1. So we do the same thing for y, access the y coordinate and store it inside y1. So with that, we can always make it a callback function so that we get the pose of the total sim, or the total in the total sim. Now the next thing we want to do is to write the callback function for our Euclidean distance server. So let's just call it EDSCB. CB is just short for callback. So, and this is going to take two arguments. The arguments are the request. Remember, in services, you have request and you have response. And in this case, for example interfaces.srv, we have two requests inside, the int64a and the int64b, and then we have the response, which is int64 sum. Okay, so we're just going to take the request and then we'll say add to int dot request. Okay, and then the next argument is the response. Okay, the response is gonna be add to int dot response. All right, so again, this is where we have the instance. Request is this request here is an instance of add to int dot request. This response is an instance of add to int dot response. So it means that request can access the variables inside add to int request, and response can access the variables inside add to int response. All right, so I'm just gonna move on. And then what we want to do first is to make sure we have a global variable. So this time we're referring to our x2 and y2. And what do we want to do? We want to take the request.a, we want to store it inside x2. So x2 is going to be request dot a. Now we have the next one, which is y2, and y2 is going to say request dot b, and then that's y2. So remember again, because request is an instance of add to int request, we can always use that with the dot operator to access the variables inside add to int request. Okay, and the variables are a and b. All right, so basically we're taking the not really taking the inputs, but this is going to be like the inputs from the client who is trying to make a request. Okay, so then go to another line that says print incoming coordinates. So we just want to show the users what we're trying to do. So just give them print. Now you will realize that I didn't use the RCL, the get logger, and it's because the get logger will only work when you have a node. So it's through the node that you can use the get logger. But because there is no node here yet, I cannot use the get logger. It's not going to work. So what I just have to do is to use my normal Python to print on the screen. And that's what I'm going to do now. Incoming coordinates. So I want to show people that, hey, we have some incoming coordinates, and the incoming coordinates are the x1, y1, and x2, y2. So to do that, I'm just going to use a placeholder, the d, comma d. So you use that for integer variables. And then I'm going to use another one, placeholder d. So those are placeholders for integers, and then d again. So and then I'm gonna put the sign, and then start putting the placeholder. So the first one is the x1, then followed by the x2, then x, No, x1, y1, then followed by x2, then y2. So what this is going to do is that this first percentage sign and d is going to be replaced by whatever the value of x1 is. The next one is going to be replaced by whatever the value of y1 is, and so on like that. So the formats this way is important because they follow the same order. So the first one will be this first one here, the second will come here, the third one here, and the fourth one here. Okay, so printing incoming coordinates, and after that we want to take the sum and calculate the sum. Now in this case we call it sum because that is what the response is called in the message file. But actually what we're just trying to do is not just sum, but calculating the distance between 2 points. Now to calculate the distance between 2 points, and then we'll calculate it and store it inside sum. So this is where we want to store it, inside response. Remember again, response is an instance of add2int response. So it's just going to store it inside sum. But what do we want to store inside sum? What we want to store inside sum is the distance between 2 points. To do that, I'm just going to say np, remember that's from our numpy, dot square root, okay, np dot square root, and then we want to take square root of something. So that thing we want to take square root of is np dot square. So we want to, okay, square, we want to square x2 minus x1. Okay, we want to square that, and then plus, you can refer to the C++ version of this same lesson so that you know where we get the formula from and you know the objective of what this code is trying to do. So then we do np square. Okay, so we want to square y2 minus y1. All right. So that's basically what we want to do. You take the square root, you take the square of x2 minus x1 and the square of y2 minus y1, you add them together. So after adding them together, then you take the overall square root. Now, because sum is an integer, and this one is not going to return an integer, it's going to return something like a float or a double, something having decimal point. But remember, our sum is an integer, so we're just going to convert this sum to integer. So to do that, we will do something called typecasting. So we're going to cast this decimal point number to an integer. So I've casted it into an integer. So for instance, if the answer, after the calculation, if it returns like maybe 5.2, it's just going to cast it into 5 instead of 5.2, and the 0.2 part is going to be truncated because it's an integer. So, and then when we are done with that, with calculating the sum, we want to print the answer on the screen, and then we just say, hey, sending back response. And the question is, what is the response? The response is what we put here. So I'm just going to use a placeholder D again. Then we put the response. So the response is response dot sum. Okay, response dot sum, and then we return response. Response. All right, so this is going to be our callback functions. The first callback function is the one that gets the pose of the total, while the second callback function is the one that calculates the sum of the 2 points. Okay, it's going to calculate the sum of the 2 points and then return response. So we now need to write the main function. So we call it main. Now it's the main function that's going to process all these things we've been doing so far. So So we're just going to do args is equal to none, and then the main function. Remember, you have to initialize rows. Without that, it's not gonna work. So you have to initialize rows. After initializing rows, you have to declare your node object. So we're just gonna call our node EDS. Yeah, let's call it EDS, Euclidean Distance Server. So that's the name of our node, and we store it inside node. So now that we have the node, we can always use it to create our publisher and every other thing like that, like our server. So the first is going to be the publisher. So let's just create a publisher called pose_publisher. So this is what it's going to subscribe. Sorry, this is a subscriber, not a publisher. So it's going to subscribe to the total sim pose, and then gets the post from that topic. So the first thing is the node, which we just created now, and then the create subscription. We want to create a subscriber. Remember, the next thing that follows is parentheses and then the type of topic or the type of message file, which is post, followed by the name of the topic you want to subscribe from, or you want to make subscription to, which is .1/post. That's the name of the topic. And then we have the callback function. So remember, the callback function is whenever I subscribe to this topic, what do you want me to do? That's the callback function. So what you want to do when you subscribe to the topic is the callback function. So whenever you subscribe to total one post, I want you to get the position of the total. Okay, and then you pass in your QoS 10 being the default for subscriptions and publishers. The next is the server. So we're going to create our server now. Remember, we have a callback function for that already. So the next thing is just to create a server. So I'm going to call it server is equal to, remember, the node is an entry point or access point to your ROS code. So without the node, you cannot access the publisher, you cannot access the server, and so many other things like that. So we're just going to do node.create server service. So node.create service. Again, what is the type of service you're using? The type is add to int. Add to int, yeah. And then the question is, what is the name of this service? The name of the service, we're just going to give it any name, but remember, we used distance between 2 points the other time, so we're just going to use it here again. So distance, these 2 points, that's the name of the service. And then what you want to do is the callback function. So the callback is eds_cb. All right, so eds_cb. What we now want to do is using the node object. You can see now this is where I can now use the get logger to use ROS to log information on the screen. The get logger, you see, I have to put in the node first before I can use the get logger. Whereas here, I cannot do that. I cannot do that here. So I just have to use the default Python way of printing on the screen. Okay, but here now I have my node, and then I can then use the get logger. So the get logger is attached to the ROS ROS client library for Python. So get logger, and then we have info. So you now put whatever information you want to put there. So we're just going to say ready to get distance between 2 points. All right, so ready to get distance between 2 points. So this is what it's going to show you on the screen. So it's going to show you this on the screen until there is a request from the client. So when there is a request from the client, then this part of the code is going to run. So but when there is no request, it's just going to keep on asking or keep on saying ready to get distance between 2 points, and then it waits until there's there's a request from the client. All right. So now, without spin, your code won't keep running. So you have to call the RCLPY dot spin. And then the question is, what do you want to spin? You want to spin the node. Without spin, your code will not keep on running. So and then we say shut down. So that is there in case you want to shut your code down. And yeah, we're almost done. So we go here and say if name is equal to the logical type main, we want to run main. Okay, so we want to run the main function, and that is all for now. Oh, we do not. Now it's because I guess what we're trying to do, add two ints here, and then it added this library. We don't need it, so please, you can, peradventure you see, you know, Python or VS Code automatically add in some libraries for you. You can just remove them. These are the libraries we need for now. So I'm just gonna save the file and then go to the CMake list. Remember, you always go to the CMake list to, you know, clear things up. All right, so this is our code. We just need to come down here and add the Python executable. So the Python executable is on the scripts slash eds.py. Yeah, that's our file, eds.py. There's no other thing to do. Remember, we already have the example interfaces when we did the C++, so line 27 is there. And then, yeah, that's that. And we already have this one just added now, the line 62, just added now. So we are good to go. The next thing is to go to your workspace. Then you want to build your project. So we run calc on build. Again, if there's any error, calc on build is going to tell us. All right, seems there's no error. So what we're just going to do now is source our workspace. Source, where is it? Install setup.bash. Oh, sourcing done. So we can now run our node or our code and then see what's going to happen. So I'm just going to say rust2 run, and what's the name of the package? .2 control, and then we have the eds.py. Yeah, so let's run it now and see what's going to happen. Yeah, brilliant. It's working fine. So it's telling us that ready to get distance between 2 points. Now, because this is just the server, it's not going to return anything yet until a client makes a request. So it's when the client makes the request, then the server is going to give a response. So in the next lesson, we're going to see how we can write our own Python client code. Okay, so we can quickly do something. Let's introspect and see what is actually going on. rust2 node list. Okay, so we can see the EDS node is running. I'm just gonna put this like always on top, drag it to the side. Let's go back to the code, and then the node. Now this is the node line 28. That's where we have the EDS. You can see the EDS node is running. Let us test and see if this service name is also running. Okay, I'm just gonna do rust2. Okay, just rust2 service, yeah, service and list. Yeah, so let's see the list of services. Wow, you can see it's there, the distance between 2 points. Okay, I know it's running. And that is everything you need to know. The next lesson will be about writing the client.